Let's talk about the solution to number 8 on the 7.2 worksheet. That is the integral of cosine 2x sine of 3x. Okay, so this one's really different from the other integrals that involve a combination of sine and cosine. Typically, you have like cosine to an exponent x, sine to an exponent x. This one's different because we're lacking the exponents, which actually is not that big of a deal. A substitution would still work. But the main difference here is that cosine has 2x in its interior and sine has 3x. So our normal u substitution approach does not work here. As soon as you see that those two interiors don't match, that means that this is a job for the product identities, which we typically don't have to memorize for tests and quizzes, but it does show up in the homework and it's worth knowing how to do it. All right, so our three product identities have this setup. There's one for sine with sine, there's one for cosine with cosine, and then the third one is what we need, at least in the order that I have them written here. A sine with a cosine, that's what we have here, a sine and a cosine with different interiors. So this will be sine A minus B, sine A plus B with a 1/2 on the outside. Okay, so in this formula, what is in the sine is A. What is in the cosine is B. All right, so I'm going to use this formula now. Very carefully. Keep that on the screen for now. Okay, so this will be integral of 1/2 parentheses. All right, sine of A minus B. So this will be sine of 3x minus 2x, and then plus sine of A plus B, which is 3x plus 2x. So now I'm done with my identity. I'll take that away, and we have to reassess the situation. Certainly one thing I could do is pull this 1/2 outside the integral, or I could distribute it in. And then I also have some cleanup to do in the interiors of both of these signs. The improvement that we have definitely made, though, is that we've gone from multiplication between these guys to, we still have two different trig functions, but there's addition between them, which means we can treat them as two completely separate integrals. Okay, so in the next step, I'm going to simplify 3x minus 2x and 3x plus 2x. I'm going to distribute the 1/2 into each piece and then split it into two separate integrals. All right, so this first one, we have 3x minus 2x conveniently is just a single x. And then plus, completely separate with its own 1/2 distributed in, sine of 5x. All right, so this first integral on the left is one that we can do just in one step with the memorized derivative rule, or antiderivative rule rather. This will be negative 1/2 cosine of x. I'm going to hold off on the plus c here because I'm just going to say plus this guy's answer, plus c at the very end. We only need one plus c overall. For this integral here, it is a small u substitution. We're doing u equals 5x, which means the du is 5 dx. 1/5 du equals dx. So this becomes 1/2 sine of u, 1/5 du. Okay, so overall, this gives me a 1/10 out front from the 1/2 and the 1/5 together. Sine will integrate to negative cosine, so why don't we just make this subtraction right away? And instead of having a u in there, I'll just go straight to the 5x here, plus c, and we're done.